Hi, welcome to Molly's Maths. 11th of January. Let's get the music on. Got a bit of George Ezra here, listening to the man. He's putting me in a good place for maths. Hope you've got your music on, and I hope it's putting you in a good place for maths. Without further ado, let's move on to question 1. Question 1. Right. Question 1 is all about telephone calls received by students. So we've got 4 students who received telephone calls. Patrick, he received 12, Andrew 20, David 6, George 9. What is the range of calls? So basically, to find the range, you need to find out who got the highest and take away the lowest, and that will give you the range of calls. So if we look at it, we can see Andrew, he had 20 calls for Andrew. So if we put that down here, 20 being the highest, minus the lowest, which will be George. No, not George, David. He had 6 calls. So 20 minus 6 is 14. So the range equals 14. Not too difficult. As long as you know what the range is, you'll be able to answer that question. So that the data is laid out there with the students and numbers. But I think there's another way of laying out the data. Let's have a look. Yeah, so you can use pictograms to represent data, and sometimes that's easier. Visual representation is easier for people to look at. These are commonly used in presentations by big companies to display their data, and they'll use different ways of doing it. An example here I've given is basically we've created a square to represent, or a cube to represent 4 calls, and then we've looked at each student, and we've put the image of the square or the cube how many times to represent the number of calls. And Patrick, he had 12 calls, so he's got 3 squares or 3 cubes. Andrew, who had received a lot more calls, he's got 5 cubes. Each cube representing 4 calls would be 20. David, he didn't seem to get many calls. He's not so popular. He only got 6, so he's only got 1.5 cubes. And George, I'm listening to George at the moment, listening to the man. He got 9 calls, which is 2.25 cubes. So it's just a visual, and sometimes it's easier for some people to look at and get an idea quite quickly of what's going on with the calls. And we can see that Andrew is looking very popular, and David, he's getting on with his work and not answering his phone too much. Anyway, let's move on to question 3. Oh, question 3, one of my old favourites. I do like the fractions, but not everybody's favourite. And this one, it's not a multiplication. This one is adding fractions. Now, adding fractions is a little bit more challenging than multiplying fractions, because you can't just add the bottom denominators and the numerators together. You have to get the denominators in the same. They have to be the same. So we have to do a little bit of a manipulation to get them to be the same. So what we can do, we need to find out what 4 and 7 will go into. And the easiest way, if you're unsure, is if the numbers are small, is multiply those 2 numbers together. And so 4 times 7 is 28. So that would equal. So we know that both of those go into 28. So if we multiply 4 by 7 and 7 by 4, that gives us 28. So what we can do here is we can put a line over there, and we can put 28 is going to be the denominator. But now we need to find out what the numerators are, which is the top part of the fraction. So whatever you do to the bottom, you've got to do to the top. You've got to do exactly the same. So we've multiplied the 3 over 4 by 7. So we're going to have to do the top by 7. So 3 sevens are 21. And plus 5 times 4 by 4s are 20. How's that looking? So now, let's get it more into a fraction than what we can. So we would have 28 at the bottom, and 21 plus 20 is 41. So it doesn't look right though, does it? Fractions are normally smaller than 1, but 41 over 28 is bigger than 1. So that's a top-heavy fraction. So we need to do a little bit more of this to get it looking, to get a good answer. So if we got 41 over 28, what does that equal, or was it? So we've got, well, we can take 28 over 28, and what have we got left? Plus, what have we got left over 28? We have got 13 bits left over 28. So, and that is the same. 20 over 28, 20 over 28 over 28 is 1. And 13 over 28. So the answer is you've got 1 and 13 over 28. It's quite a little bit of working to go on to do that and to get it down, and even if you only do part of it, you're going to get some marks. But if you can get down to 1 and 13 over 28, you're going to get full marks in the exam. But you know, there's quite a bit of practice needed with adding fractions, a bit more challenging than multiplying fractions. But I hope this helps, and yeah, I hope the music's helping as well. Let's move on to the next question. Question 4. Question 4, indices. Once again, indices can be a bit frightening for people, but I mean, there's really only a couple of rules with indices. What you need to do is when you've got indices the same, when you're multiplying indices, you just add them together. So if we multiply, if we're multiplying it, we need to add. So that would be, so m, so we just add the 2 and the 6, and that will give you m to the 8. So that's multiply. I'll put multiply there. So when you divide, you do the opposite. Equals sub, you take away. So m to the 6 divided by m to the 2 will equal, basically, I'm going to put it in here, 6 minus 2 equals m to the 4. So there you go. So indices, if you're multiplying, you add them together, and if you're dividing, you take them away. I hope that's helped a little bit. Again, I would invest a little bit of time looking at indices and maybe having a look and getting doing some home study on them. Yeah, but they're not as frightening as they look. Let's move on to the next question. Oh, question 5. It's calculate the circumference to 2 decimal places. Well, given a circle here, and the circumference is basically the outer edge of the circle, and anything with a circle is going to involve pi, which is we always use it in the calculations. And to find the circumference, basically we just got C is the circumference. It's going to equal, it equals 2 times pi times the radius, r, the radius, which in this case, we've got it on the diagram, it shows us 7. And so we get the old calculator out, and the answer is 43.98, because when we're going to make it 2 decimal places. That is 43.98 centimetres. And we've done the answer to 2 decimal places. So I'll just put 2 dpi, because that's what was asked for in the question. So it's 43.98 centimetres. So basically, once you've got the formula, which is C equals 2 pi r, you look on your diagram, you find the information. We know what pi is. Pi is 3.14, and it goes on forever with loads of numbers, but your calculator can do that for you. And we got the radius, which is 7, so it's just a matter of following the formula, and you get to the answer. So that's 43.98 centimetres round there. Right. I think that concludes all the questions on here today. And again, I hope you've enjoyed the maths and enjoyed your music, and have a good day, and see you soon again for some more Molly's Maths. Keep smiling, and goodbye from me.